Welcome. Welcome again. Last lecture in Kinetics and Equilibrium. Again, I'm recording this for those of us who missed class or need a review before the test. Here we go. Enthalpy and entropy. Our learning target here is to read and interpret chemical equations to predict changes in entropy, which means randomness and disorder. So the things that we're going to be looking for is phase changes that create disorder and energies being released, which creates disorder. So, what is the motivation for all chemical and physical reactions? It is to reach and obey the laws of thermodynamics. They want to get stable. They want to reach stability. And the lowest energy state possible is when all chemical products are most stable. So these laws also indicate that the universe favors random and disordered state because that is lower energy. It takes less energy to have a messy room than it does to clean it up, doesn't it? Things don't fold themselves when you throw them in the dryer. Be cool, but they don't. Take that pile of laundry you got and put it into the washing machine. It gets all mixed up inside there. The universe doesn't organize things for us. We have to put energy in to make that happen. So the universe favors the chaos, randomness, and disorder. If left to its own devices, a brick wall would eventually crumble and fall apart and become sands and dust. It doesn't build itself up. We have to put energy in to make that happen. So the universe tries to break that back down. Entropy, order, and chaos changes. So draw particle diagrams to illustrate each of the following phases. And these are in order of increasing entropy. Solids, we've got our particles arranged in the bottom center of our container. Liquids, they're touching and filling the entire bottom of the container. Aqueous, we've got liquid and the particles dissolved in it. More random and disordered, but in a gas, there's no liquid and the particles are just like all over the place. So, highest order, lowest order. We'll use the word lowest entropy, aka high order, and the highest entropy, aka the least order. Let's see what else we got here. Oh, those were drawn in for us, so add them to it. No randomness. Some randomness, a little bit. More randomness. And, well, we've got the highest, most randomness. Okay. Entropy increases when samples are turned from solids to liquids to gases. Solids are liquids dissolving in water. There's liquids to gases. And gas, as a product, is usually when entropy increases. Reaction produces more moles of product than more moles of reactant, so you're producing more stuff than you consumed. Makes more randomness. And here's examples of finding changes in entropy. You got to look at the little letter codes and the mole coefficients. Okay? For example, 1 reactant, 2 products, 2 moles, 5 moles. Entropy increases because we're producing more products than we consumed, and therefore they must be more random. In this next one, number 2, we have a liquid becoming a solid. Well, that is going down. Entropy is decreasing. It's becoming more ordered as it freezes. The third one, we have 2 things, two reactants becoming 1 product. We have 4 total moles and 2 total moles. So the randomness and disorder is decreasing when that one particular formed. This solid is becoming aqueous ions. That's an increase in entropy. This solid is melting and becoming a liquid. That is an increase in entropy. This solid's turning into a gas. That is an increase in entropy. These aqueous ions are reacting to become a liquid. Two things become one. That's a decrease in entropy. A solid and a gas make a gas. Two reactants, one product. That's a decrease in entropy. Two gases becoming another gas. This is 2 moles becoming 2 moles. This one is kind of even. It's almost a wash, but it's still two things becoming one. Two reactants becoming one product. So some would say the entropy decreases. Others would say it stays the same. I'm on the decreases side of things. Two aqueous ions becoming a solid product. Entropy is decreasing. I hope you start to see the pattern that I'm doing. I'm looking at the letter codes, the number of reactants, number of products, and deciding, are things getting more crazy and random, or are they getting more ordered? And that's entropy, okay? Which brings us to the end of this particular unit. Thanks for watching. I hope you use these to review and study for the Regents exam and our unit exam as well. See you next unit. Bye.